Welcome to this explainer. Today we're tackling something that trips up almost everyone at first, the Linux directory tree. You know, if you've ever found yourself totally lost in this sea of cryptic folders, just wondering where on earth did my software actually install itself, well, trust me, you are definitely not alone. So our goal today is to demystify this map. We're going to take what looks like absolute alphabet soup and reveal the brilliantly organized structure underneath. To kick things off, we really have to ask the most fundamental question. Where does everything actually live in Linux? If you're coming over from other operating systems, you're probably used to a very specific way of finding your files. But Linux, it approaches storage with a completely different philosophy. So to truly master it, we kind of need to undergo a bit of a paradigm shift. Think about a traditional OS. Your storage is completely fragmented, right? You've got different drive letters, a C drive, maybe a D drive, an external E drive. They act like isolated little islands of data. But Linux does this entirely differently. It organizes absolutely everything into one continuous unified tree. Every single file, program, device, and even active processes, they all trace back to one single starting point. It's an incredibly clean structure once you see the big picture. To make sense of it all, we're going to take a quick, guided city tour of the file system, breaking it down into 5 highly logical districts. First, the root and essentials. Second, users and installed software. Third, virtual systems and hardware. Fourth, temporary data. And finally, external mounts.
All right, let's jump right into District 1, the root and essentials. This is the absolute core foundation of the system.
Everything, and I mean everything, begins here at the root directory, which is written simply as a single /. The really fascinating part is that absolutely everything on a Linux machine exists beneath this one slash. When you type cd/ in your terminal, you are essentially teleporting to the very top of the hierarchy. All the branches we're about to explore, they all connect directly back to this one single point.
Right under that root, we find our main executable directories, and they're categorized by their exact purpose. First, you've got /bin. This stores the essential command line tools your system absolutely depends on, like ls or cp. Because they're critical for startup, they sit right next to the root. Then there's /sbin, which holds administrative tools used by the root user. Think fdisk for managing partitions, or the commands to reboot. And then you have /usr/bin, which holds your general everyday user software. Keeping these separated ensures the OS always knows exactly where its critical startup tools are versus just standard apps. Next up in this foundational district is the /etc directory. Now, unlike those bin folders we just looked at, you actually won't find any executable programs in here. Instead, think of this folder as the system's absolute rulebook. It holds all the critical configuration files that dictate exactly how the entire system and all the services running on it behave. To really grasp the power held in this folder, just look at a few of these key files. You've got the password file, which manages user accounts. There's fstab, which is totally crucial because it controls which physical drives mount automatically when you boot up. You've got resolve.conf, defining your network's DNS servers, and the sudoers file, which dictates exactly who has permission to run administrative commands. Basically, if you want to change how a service operates on Linux, you're almost always going to be tweaking a text file right here in the etc directory. Okay, moving on to our next neighborhood, District 2, users and installed software. So, we have 2 very distinct spaces here. On one side, we have /home. You could think of this like personal user apartments. Every user gets a folder named after them here, and it stores all their documents, downloads, and hidden config files, like those bash profiles that customize their specific terminal. On the flip side, we have /opt. This is much more like an industrial park. It's used as an isolated container for massive third-party software that gets installed outside the normal package manager. Really large applications will drop all their files, libraries, and resources into one self-contained folder in opt, keeping them completely separated from the main OS.
And that brings us to the /usr directory. Now, despite the name, this actually doesn't hold user files. Remember, that's what the home folder is for. Instead, USR contains the vast majority of the software installed on your system, and it's incredibly well organized. You've got USR/bin for the installed programs themselves, USR/lib for the shared libraries those programs actually need to run, USR/share for data like documentation and system icons, and USR/local, That last one is safely set aside for software you compile and install manually, which keeps it perfectly safe from being accidentally overwritten by automatic system updates.
Let's head into District 3, Virtual Systems and Hardware. This is where you see the real magic of Linux. So in Linux, hardware devices are actually treated as files, and they all live in the /dev directory. You're going to see files like SDA, which literally represents your physical storage drive. But it gets even cooler, because the dev folder also contains these amazing special virtual files. You have dev null, which is famously known as the black hole of Linux. Literally anything you send there is just discarded silently. You've got dev 0, which outputs an endless stream of 0 bytes if you ever need to securely wipe a drive, and dev random, which uses environmental noise to produce cryptographic random data. That's incredibly useful for generating security keys. I mean, these aren't real files on a hard drive. They're direct functional interfaces to the system's capabilities. Building right on that concept, we have two directories that don't actually exist on your hard drive at all, /proc and /sys. The proc file system is this dynamic, real-time virtual window created on the fly by the kernel. It gives every single running process its own directory, letting you peek directly into memory usage and active commands. The sys directory is pretty similar, but its focus is hardware. It dynamically exposes info about USBs, PCI components, and network interfaces. Get this, administrators can actually adjust hardware behavior on the fly simply by writing text to a file inside the sys directory. How crazy is that? Moving right along to District 4, Temporary Data. This is all about managing the chaos.
First up here, we have our highly ephemeral data, which is managed by the /tmp and /run directories. Applications use TMP as a sort of massive whiteboard. It stores brief working files while you're, say, editing a document or extracting a large archive. In fact, on modern systems, TMP often exists entirely in RAM for lightning-fast speed. The run directory is similar, but it's meant specifically for system services, tracking active process IDs and communication sockets for the current boot session. The absolutely crucial thing to remember here, both of these directories are wiped completely clean automatically the second you shut down or restart.
But obviously, not all changing data can just be thrown away. That's where the /var directory comes in. It's named literally for variable data. This is the busy hub of persistent change on your machine. It holds data that changes constantly during operation, but absolutely must survive a system reboot. So what exactly lives in var? Well, this is basically where your system writes its history. All of your system logs live in var/lock. When you update your OS, the downloaded packages are temporarily stored in var/cache. If you queue up a print job or an outgoing email, it waits in var/spool. Databases and application state files, they live here too. Because it's constantly being written to, the var directory is, without a doubt, one of the busiest, most active parts of your entire system during normal operation. Finally, we reach the edge of our city. District 5, External Mounts, Connecting Outside Data. Since we know Linux is a single continuous tree, you might be wondering, how do we handle outside data, like a USB thumb drive, and connect it securely to that tree? Well, we have two distinct directories for this, /media and /mnt. The distinction here is all about intent. The media directory is generally used by your graphical desktop environment. So when you plug in a USB drive or an SD card, the system automatically mounts it inside the media folder so you can access it instantly. On the other hand, MNT is the traditional location used for manual intentional mounts. If an admin needs to temporarily hook up a massive network share or manually mount a raw disk image via the terminal, they'll attach it right to the MNT directory. And that really brings us full circle. Looking at all of this together, you can really start to see the beauty of the unified tree. We just explored 15 incredibly distinct directories. We looked at physical hardware devices, virtual representations of memory, constantly shifting logs, and just static personal documents. Yet, despite how wildly different all of those elements are, they all snap together seamlessly into that single, highly logical root structure. It leaves us with this really provocative thought to end on. If everything in Linux, even a physical hard drive, even real-time RAM, even endless streams of cryptographic data, if they are all just treated as files residing on a single unified tree, how does that transform the way you navigate and control your computer? Think about it. It completely removes the mystery. It puts all the power directly in your hands, accessible through a simple terminal path. So I highly encourage you to open up a terminal, type cd/, and start exploring this beautifully constructed city for yourself. Thanks for joining me on this explainer, and I'll catch you next time.